Hello everybody, welcome to AWS Bytes Live. Luciano and myself, Owen, we're back with episode 3. So this is our third live stream. And so far we've built a pretty useful but a little bit basic file sharing application on AWS using S3 and pre-signed URLs. And we were able to share files with our friends and with colleagues using a HTTP front end. So just using curl, and that was calling an API gateway REST HTTP API, and behind that we had some Lambda functions and of course S3. Last week what we were focusing on was making the download URL a little bit nicer, getting rid of some of those ugly S3 pre-signed URLs which are incredibly long and complicated. We also used the content disposition header last week so that we could download the file with the correct file name. And this time, we're going to focus on making it a little bit more friendly from a user experience point of view. We have everything live in a GitHub repository, so you can find that on the AWS Bytes org on GitHub. The application is called Weshare.click, and that's the domain we're deploying it to. So last week, one of the things we did was set up Route 53 certificate manager, so we also have HTTPS URLs. So this week we're going to focus on a couple of things, right? One of the things is just answering a few questions we had from last week, focusing on improving the observability. What's the word? It's observability. So we're going to add some support into code to make sure we got good tracing, good logging, good metrics. And we're going to use the Middy framework and for the first time. So Middy framework is really useful for Lambda functions for a lot of different use cases. We've already done a podcast all about it on AWS Bytes. So we're going to get a flavor of that. And if we have time today, we might start our command line interface front end so that we don't have to worry about curl anymore. And I'll be very happy once we can put curl in our rear view mirror and have a much nicer UX. So Luciano, where should we start?
Yeah, so should we give a brief intro on Middy and PowerTools? Maybe I can try with Middy and you can try with PowerTools. What do you think?
Yep, let's do that.
Okay, so I'm gonna share my screen super quickly. And, well, maybe not that quickly, because it always takes some time to find the right screen. So if you go to this website, middy.js.com, and by the way, we have Will here, who is not just a big fan of Middy, he's also the maintainer, which has been doing an amazing job for the last 2 or 3 years now. I'm starting to lose track. But he's the main author behind basically V2, V3, and whatever is coming next. So big shout out to Will if you like what we are going to talk about today. So
I'm very nervous that I'm going to say something incorrect about Middy, but that's okay.
Yeah, me too, probably. So Will, please forgive us if we say anything stupid. And feel free to correct us as well. So the main idea behind Middy is basically that when you start to build something a little bit more complicated, like for simple hello world lambdas, you probably don't need Middy. But when you are starting to build a real application with multiple different lambdas, probably at some point you end up with a lot of code duplication across all your different lambdas. And it is a little bit of a pain to kind of keep all that code in sync and organize it in a way that it makes sense. And so that the Middy tries to help you to keep all your code cleaner and reuse as much code as possible across lambdas. And I want to show, this is the website, I want to show, well, here there are some kind of selling points, but let's ignore them for a second. So that this is actually the example I want to show, that in a realistic lambda, you generally have a bunch of stuff that happens there. And you can generally split it in 3 parts. There is a bunch of like pre-business logic stuff. Then there is your actual business logic. And then you have post-business logic. And just to give you an example, generally pre-business logic is like, I don't know, you need to read some environment variables. Maybe they are encrypted with KMS and you need to decrypt them. Then you are receiving maybe an event that needs to be deserialized in some way. The simplest case, it's an HTTP request with a payload in JSON. You'll need to kind of JSON parse that. But of course, there might be multiple variations of that where you need to parse the content in different ways. Then there might be, I don't know, input validation, authentication, authorization, all these kind of different concerns that you need to take care of before you can actually start to run your business logic for that Lambda. Then you have your real business logic, which probably is going to produce some result. And after that, you have a bunch of other concerns like, I don't know, validate the output, serialize the response, handle any potential error. So the promise of Lambdas and function as a service in general was that we should have been able to focus 100% on the business logic. But then we find out that in reality, even when you use Lambda, there is still a lot more that goes on. And you need to take care of all of that if you want to build kind of solid applications. So what Middy does, tries to externalize all these concerns, like remove them from your handler. So your handler tries to be as pure as possible and only focus on the business logic. Of course, assuming that all these pre and post things are done for you, and it's assuming kind of the best case. And then once you have all these things externalized, they become independent units that you can easily use, you can easily test, and you can attach them only in the Lambdas where you actually want to use these additional pieces of functionality around your business logic. So in a way, it's not too different from what Express does with the middleware pattern. For instance, in Express, you can use the .use to attach, I don't know, an authentication layer or an authorization layer or an error handler layer. It's really the same idea, just applied to the context of AWS Lambda. Now, I hope that I'm giving justice to Middy. Will, feel free to add anything there in the chat, and I'm going to highlight it if there is anything important that I'm missing. The cool thing about Middy is that it's very modular because, of course, it tries to respect the principle that the smaller your Lambda package, the faster it's going to be the bootstrap, the easier it's going to be the deployment. So it tries to give you as little as you need to keep going, and then you can add more stuff when you need more. So it's very modular, it's split in multiple packages. There is a main package, which is the core, that only implements the middleware engine in itself, and then you can add more packages depending on what you need. And there are some official packages, but also there is a community of middlewares that there are community provided middlewares that you can find on GitHub, and you can use them. So on the website, if you go on middlewares, you can see that we have official middlewares for all sorts of use cases. For instance, to do all sorts of request transformations, response transformation, fetching data from different sources, plus additional stuff like error logger, input-output logger, keeping your Lambda warm. So Middy tries to give you all the things that we have seen most commonly requested by people. So you can just install all these different packages. Probably today we're going to be using this one just to show you an example. And the way you use it is that you just install this specific package other than the core and then use it that way. But we will see that in the code in a few seconds. So yeah, that's all I have. And another reason why we're using Middy is because it's one way of using PowerTools, but I'm going to give it to Owen to try to explain what PowerTool is and why it can be useful and why we want to use it today.
Okay. Yep, great. So PowerTools, I started off using the PowerTools for Python, I think like a lot of people. And the idea was, I think PowerTools actually for Python was also inspired a little bit by Middy and also by the DAZN PowerTools and maybe Lumigo PowerTools, concepts that were out there. And they also have similar goals, which is to try and ease the amount of boilerplate you need to do in Lambda functions if you want to do best practices. So PowerTools is specifically focused on basically 3 pillars of observability. It's focused on tracing, logging, and metrics. And I'll just maybe share the screen as well so people can see the documentation. So I'm just showing the Lambda Power Tools for TypeScript homepage. And this is pretty new. It was only in the last 4 to 6 weeks that this was made generally available at release 1. We did do a blog post on this as well on the Fourth Year blog, which we can share in the comments. And the idea with the PowerTools for TypeScript is same as with the Java version and the Python PowerTools, is it makes it really easy to do good practices around logging and metrics and tracing. So these things are quite simple concepts, but you can end up having a lot of boilerplate and having a lot of utility functions around your code, and PowerTools makes that easier. The ones that have been around for longer, like the Python version, have a lot more features than just doing tracing and logging and metrics. So they have support for example, building in item potency into your Lambda functions, which is really important, and a lot more features besides. But we're just going to focus on logging, tracing, and metrics today, and we'll talk about how to add these in. If you're using TypeScript, there's a number of ways of hooking PowerTools into your Lambda functions. If you're using TypeScript, you could use decorators. And if you're not using TypeScript, one of the best ways to do it, I think, is using a Middy middleware. So you can add a Middy middleware for tracing, one for logging, and one for metrics. And you'll get instant results in terms of what you see in CloudWatch and in X-Ray. In your logs, it'll give you structured logging, but it will also inject some Lambda related properties into those logs. As regards tracing, it will give you trace segments that are capturing your Lambda function handler. And for metrics, it'll give you an easy way to do embedded metrics. So custom business CloudWatch metrics in your application as well. So we can look at all that and see what it looks like as we build this out today.
Awesome. That's a great intro. Feel free to ask questions in the chat if there is anything else you would like us to cover, or if it wasn't clear. If not, I'm going to share my screen and we can start to look at code and add stuff there.
Great.
So this is the code from our repository. Let me know if it's too small or not readable in any way. But yeah, we had a bunch of files. The main two files that we're going to touch today are the share handler and the download. The share handler is the Lambda code that allows us to basically create a pre-signed URL for uploading a file, while the download is the Lambda that allows us, given an ID for a file that was already uploaded, allows us to download that particular file. So it's going to effectively redirect us to a pre-signed URL that allows us to get the content of a file. Now before we actually start to integrate Middy or PowerTools, we had a quick point by Will last time saying that all this code here is totally unnecessary because since this ID is a path parameter, so we have like weshare.click /share/ID, I think. Since that /ID is a path parameter, API Gateway will already return a 404 if we don't give that value there. So this is totally unnecessary and we can remove it. Another point that Will made is that when you use content disposition, which is something we do here, there are some things to be aware in terms of security. I'm going to be intentionally vague there just because I haven't done my research. But the point is that you receive a file name. This is given by a user. So users have control on giving you all sorts of weird file names containing special characters, containing slashes, containing dots, double dots, and slashes. So trying to do maybe all sorts of different kind of attacks against the file system that then is going to download this file and try to apply that particular file name. So it will be a good practice to sanitize that received file name before we actually do anything with it. But we are going to maybe cover that in another episode just because we want to spend a little bit more time looking at the sanitization options and trying to make sure that we can describe a little bit better what's going on, what are the issues, and how the solution will fix all these possible issues. So for now, just be aware that we are not sanitizing. We should be doing it. How, we will see it in the next episodes, probably. Okay, so let's start now by probably installing a bunch of stuff, right? So the first thing that we want to install is Middy core. So we are already in the backend folder, so we can do npm I save Middy core. So this is just gonna pull the main dependency for Middy and add it to the package.json and our node modules folder. So you could see here that now we also have Middy there. Okay, then the next thing that we want to do is to start to bring in PowerTools, and we want to add all the three different things that PowerTool gives us. So metrics, tracing, and logging. So they are also organized in independent packages. So in order to get all of them, we need to do something like this. I'm gonna copy paste because I'm lazy. But it's literally AWS Lambda Power Tools / metrics, AWS Lambda Power Tools / tracer, and /logger. Okay, at this point, we should have everything we need to start updating our code. And if there is any dependency missing, we can add it as we find it. So let's start from the share handler. So what do we want to do is to import a few things. We want to do metrics and log metrics from AWS Lambda Power Tool metrics. Similarly, we want to import the tracer and capture Lambda handler. We will explain all of that stuff in a second.
This will become obvious.
From tracing, thank you, our pilot, and logger as well, and inject Lambda context. All the stuff I'm copying from a boilerplate that I have, but yeah, it is a little bit of boilerplate that you probably end up doing in all your Lambdas if you use PowerTools. So now we have all the dependencies we need. We'll need to start creating instances. So for instance here, before creating the S3 client, we could create a tracer instance by just saying new tracer. We can similarly create a logger, new logger, and metrics as well. Okay, then what's the next thing that we need to do? We'll need to import Middy, because this is how we can attach these things that we just created. So let's import Middy from Middy core. At this point, so how do we use Middy? So Middy is basically, it's gonna wrap your own Lambda handler. So we have here handle event is our original handler. So what we are doing right now, we are exporting this. But now what I want to do is actually just gonna save it as a constant. And then here, what we can do is, let's call it Middified handler, I guess. We can do this, and then we can export Middified handler as a. Actually, we call it handle event. Let's just do this for simplicity.
Okay, just going to override it. Yep.
Export. Oh, what's the syntax there?
Okay,
I'm blanking here because this is a constant. We can do export default, but this is not what we want to do. We want to export it as a constant.
You can do export const handle event equals Middy handle event. I think that'll work anyway, won't it?
Yeah, let's do it this way. But then
I don't know what the other way is.
I think it's already called. So let's just call
it. Okay, of course, yeah. You can't, yeah. Will has it in the comments. It's export const and then an object with handler.
Right.
Export default. Oh yeah, export default. Yeah, that makes sense as well. Yeah. Okay. Yeah, const is yeah, that should be default. Yep.
So let's keep it handle event so we can be consistent. And then we do here we do handle event equal midday. I want to break this down into multiple steps. Just
That's it.
I
Okay.
think it's gonna be easier to understand. And of course, you can do it in one-liner in real life.
Yeah.
Okay, so once we do this, so let's try to explain what happens here. So the first thing that happens here is that Middy basically takes your handler, so it takes all the business logic in your function, and it gives you back a more powerful version of your original handler. And it is more powerful because now you can use methods to basically add all the different things that you want to happen before or after your business logic. And the way you do that is very similar to Express. So you can say .use, and .use, you can start to add all the middlewares. So for instance, one of the middlewares that we want to do is the logger. So we can say inject Lambda context, if I can type today. And Lambda context takes a logger, and then you can pass a configuration option. For instance, log events .true. If I remember correctly, this basically means that by default, every time the Lambda is triggered, the event itself will be automatically logged without us having to do console log event. And it will be logged together with like a JSON log with all the additional context information. Then very similarly, we can add more behaviors. Another behavior we want is metrics, so log metrics. And another one is tracing is the one missing. So capture Lambda handler tracer. Okay, and I think that's all we need to do to start to use this. Now we are not logging anything. Maybe it would be nice to log something. What do you think?
I think that's a good idea. Yeah. What could we log? We could just log the ID maybe that we generate, for example.
Okay, or maybe the entire key. Because
we could log the ID and the key. I mean,
so if I remember correctly, the logger is going to be available in. Actually, here we can use the logger itself like this.
We can use a logger instance, yeah. So we can logger.info.
Logger.info, and we can say, something like this. Is that gonna be okay? What do you think?
Yeah, we can also. I think we can also log it as an event. So if we wanted, we could put an object with the key and the ID even in as the first logger argument, and that way we would have those fields available as structured log properties.
And that's the first idea.
I believe it's the first. I'm just checking that because I think it should be, but I just want to check that that's the right syntax for this one. Okay, it should be the second parameter.
Okay, that makes more sense to me. At least it's more consistent with the Python one.
It is. Well, in Python it's an extra parameter. It's a named parameter with extra, right? But in Pinot and I think Bunyan also, it's the first argument in JavaScript, isn't it?
Interesting. Yeah, it could be. Okay, so we can do this and we can see then how this information gets logged. Anything else? Maybe the file
One,
name. Let's do it here, and then we can
okay.
keep also file name and content disposition header.
Okay. Should we add a metric while we're at it?
Let's add a metric. Yeah.
So we don't have very much we could really add at this point, apart from maybe just incrementing the metric every time somebody creates a share.
Oh, look at that.
So,
You like it?
ooh,
Suggestion?
I like it, but I don't think it'll work. I don't think there's an increment. It's new to me if there's an increment function. I thought you had to do
something like stats D. I don't know.
Yeah. I think it's. I think you have to do log metric. So let's just open up the API docs here. Oh, add metric. Yeah, metrics.add metric. And then you would give the name of the metric. So create share is fine. And then the second one would be the unit, so that there is a metrics unit class that you can import from the metrics package.
So we can add it here, right?
Yeah, metrics unit, exactly, yeah. I think it's units, yeah, plural, yeah. Dot count, indeed it's a count metric, and one, yeah, we're adding one share.
Okay, perfect.
So that's the thing. Now, one of the things you can do with your metrics is add default dimensions, but yeah, let's leave that for now. I think we will need to add some environment variables for these things, because you need to have like the namespace for your metrics, and the logger will also like to have your service name. So I think in our serverless.yml we can add those things.
So we can do that in our serverless YAML. We can add it for both lambdas, could be the same, right? So we can add it here, right?
Yeah, exactly. Yeah, exactly. The service can be the same for both.
This is service underscore name.
With PowerTools underscore at the start.
Power all in one word, right?
All in one word, yeah. So we could call that Weshare. Yep.
And
why not?
The other one is
PowerTools metrics namespace.
Underscore, I suppose.
Yep, and Weshare is also pretty good.
Perfect. So we should probably do the same for the download lambda, and then we can deploy and test if everything is working as expected, right?
Yeah, so we did add the trace. Did we do everything for the tracer in share handler already?
I think so. Let's review. So we did import the tracer, and then we added it here.
Yeah.
There. Is there anything else we need to do?
I think that's it. That looks good.
Okay, perfect. So and let's do something similar also for, I'm going to copy all of this because I'm lazy, for the download URL. And then we can copy all of this in here. And then we need to do let event, and I'm going to copy all of this as well. So there is still a bit of boilerplate, but all the different additional behaviors are now isolated on their own utility function, and they are tested in their own independent packages and so on.
Yep.
So cool. So next thing that we need to do is, do we want to log anything in the download? It seems pretty important to me to log that somebody's downloading a file, right?
Yep.
So maybe let's log here, logger.info, downloading as key. or what did we call it? ID.
Yeah. Yeah, I mean, I would normally tend to actually put none of the properties in the string and leave them all in the structured logs, because then there's all the data is going to be there, and then you can do an exact match on the message if you want to.
Fair enough. Let's do the same here just for consistency, creating share. And then
Okay.
we have ID, key, file name, and so on.
Great.
Perfect. Okay. So, and we want to add probably a metric here as well, right?
Yeah, that's a good idea. Yeah.
Download share, metric count 1. Perfect. Thank you, Copilot. Makes sense.
Perfect. Yeah, and we could build a dashboard showing the percentage of downloads the ratio of downloads to uploads. Might be interesting.
Should we try to deploy?
Yep, sounds good. While that's deploying, one of the things you can do with metrics as well with the PowerTools is you can tell it to log cold starts as a metric automatically, which will give you cold start metric data that you can analyze later if you're looking at performance.
Does that happen by default, or is something you need to configure explicitly in the configuration object?
Yeah, it's a specific property. So when you use the log metrics middleware, you'll add in metrics, and then the second argument is a set of configuration options, and one of them is capture cold start metric. And if you give it a value of true, then that will create a EMF metric. And I'm not sure, maybe we can explain what EMF metrics are all about and also show what they look like, but it will create a cold start metric then, which you can look at in CloudWatch metrics.
So give a super quick description while this is still deploying.
Yeah, okay, I'll try, and let's see how far we get. So the idea of EMF metrics, in the olden days, a couple of years ago, if you wanted to add a metric into CloudWatch, you would have to use the put metrics API in AWS. And this is a SDK or API method you could use, and it will put a metric into CloudWatch. You give it a namespace and some dimensions, the name of the metric, the unit, and the value. If you wanted to do that quite frequently, it could end up slowing down your application, and it also had a cost because every put metric invocation had an associated cost. So since a couple of years ago, the new possibility was introduced, and it's called Embedded Metrics Format, or EMF. And what EMF allows you to do is log a structured JSON log in your CloudWatch logs, and this will automatically get picked up by CloudWatch and turned into a metric. So it has a couple of advantages. You don't have to call put metrics anymore, so you don't pay for put metrics. And it also means that you don't have the latency involved in the API call to put metrics. So it's just writing to your standard out, which gets picked up by CloudWatch logs, which gets turned into a metric. So it's very cheap in terms of cost and performance. I suppose that the third benefit is that since it's there in your logs, you can actually analyze your metrics by analyzing your logs as well. And this is like a third nice side effect you get with EMF metrics. Because normally with CloudWatch, they store metrics in aggregate form, and the smallest aggregation level is 1 minute. So if you want to analyze metrics at a finer grain than that, you can use CloudWatch logs insights and actually analyze these structured EMF metrics, which is pretty nice. And you can also see them like inline in each request as part of our request logs. So it's really nice. The format itself is quite bizarre and hard to read.
You can see it here on the screen.
Yeah, it's designed for machine readability and not human readability, but you'll get used to it.
And yeah, you can probably create libraries. I mean, PowerTools is one of those libraries that make it easy for you to build behind the scene this kind of objects, so you don't really need to concern yourself too much with creating these objects yourself.
Yeah, and since you can log multiple metrics in one line, PowerTools takes care of bundling them into individual metrics line and flushing them at an optimal rate. So it actually buffers them and then flushes them just in time, or you can flush them explicitly if you need to control that.
Okay, so now it is deployed. What do? Do we try to let's test it.
Yep, let's do that.
Again, my editor. And here what we can do is curl x put. I think we can reuse. No, it was a post to this one.
Post, yeah.
So what this is doing is like trying to create an upload for package.json. An internal server error. So we did break something. What did we break? Let's go and figure it out.
Did it package our modules correctly, I'm wondering?
Good question. So let me switch screen and we can look at the logs. So here we should be able to see the logs and try to figure out what went wrong. Oh, no recent invocations.
If we go directly to log groups in the, or you can click view logs in CloudWatch, that button there, I think that'll bring you directly to the plain old log group view. And you won't have the latency that CloudWatch Logs Insights has.
It doesn't change my tab, so I'm gonna do it this way. See, yeah, okay, that refreshes it.
Oh yeah, perfect.
Okay, so cannot find AWS Lambda Power Tools tracing. This is a bit small. I don't know if you can see it, but there was some packaging issue there. Yes.
I think I know what this one is. I think it's packaged. It's just called tracer, not tracing.
Oh, right. So it's my own typo. Yeah, you are totally right. Perfect. Let's quickly fix that. And so this is tracer, and this one backend. Cool. That should be it. Now
Okay,
it's gonna
cool.
take it some time to deploy, and you can see the joys of debugging Lambda in real time.
Maybe we can do an invoke local. If we have another error, right, we can show how the local invocation method works to avoid having to do this deployment loop when you're dealing with these kind of niggly errors you get early on. Of course, you could also do some unit tests. That wouldn't hurt.
Yeah, we should maybe cover these topics in a dedicated episode.
Yeah, okay.
This done. Let's see very quickly if it works. Again, internal server error. So what's going on now? I'm looking at the logs and it's saying missing AWS Lambda trace data for X-ray. Ensure active tracing is enabled.
Of course. That's an obvious, well, it's obvious now that we know the problem. Yeah, we have to enable X-ray for Lambda. And we can do that in the serverless YAML.
So in the serverless YAML, how do we do that? Can we do it globally or we need to do it in both Lambdas?
We can do it globally, and I'm just going to find the syntax. I think it's under provider, and I think it's tracing, and then it's true. But I just want to check that to be sure about it. Okay, I'm looking.
AWS tracing. Okay, you can probably tell me more.
Okay, well, we can actually enable. I'm going to send a link here to the Slick Starter example, and I'm going to send it directly to you, Luciano. But it's essentially tracing with API. You can enable it for API Gateway and Lambda. So instead of just the true value, you have an object with Lambda true and API Gateway true.
Okay, something that looks like this, right?
Yeah, that's it.
Okay, this is probably one of the problems that you wouldn't see if you don't redeploy, right?
Exactly. Yeah.
Because if you invoke it locally.
Yeah, I'm not sure how it works with invoke local actually, because when you do add the tracing middleware, you need to make sure that the right trace environment variables are there. And if you're not doing a normal invoke local, they won't be there. If you're not doing invoke local correctly, they won't be there.
Okay. So hopefully this time it's going to work. And if it works, we can start to look into creating a CLI tool for interacting with our API. We can, of course, have a look at the logs and the metrics, traces, and so on. Cool. So let's give it another shot. An internal server error again. Ooh. Yeah, it's still telling us that it's missing Lambda trace data for X-ray. Ensure active tracing is enabled.
Okay. This is unexpected. So what are we missing here?
Okay, so I'm gonna look for the
go
ahead.
When I'm looking at the logs here too, Luciano, it might be worthwhile sharing that because I think there's a previous error. And it's saying that share. Yeah, maybe you can share your screen. There's a previous error and it might be causing the subsequent issue with X-ray.
Okay, so there is a previous error. Oh, handler. Yeah, interesting.
So we need to check our export.
Is undefined or not exported. So what did we export? It's a good question. So I need to figure out a better way to switch the shared screen, because this takes forever to switch from one to another. Anyway, so share handler, what did we do that was so stupid? We exported.
Yeah, so I think then the default import is an object. We want a named export, right? Yeah.
And we remove this. We just call this handler.
Okay.
And we call this
okay.
That should work, and let's do very quickly the same here as well. Okay, fingers crossed. Is it gonna work now? We accept bets. So go wild and place your bet. We need like a betting system integrated.
Yeah, I'm a little bit worried still about this X-ray warning we saw before. I don't know if it's going to go away even if we fix the handler.
If you have the tab open, could you please share it as well so I can switch between the two? You share the logs, I share the...
Oh, that's a good idea. Yeah.
Okay, it is deployed, so let's see if we get lucky this time. Yeah, now it's working.
Nice.
Now it is actually giving us the URL. So do we want to see that it created logs and metrics?
We can do that. I can see one already.
Okay, so to your screen.
Yeah. Maybe while I'm sharing as well, you can also create some more shares and maybe do some downloads. And we can see these metrics increment and more logs. Okay, so hopefully everybody can see the screen. So I'm sharing the latest log entry and we can see a couple of invocations. So the first thing we see is creating share. So this is the structured log that Luciano added, and we can see the service, and we can see this is all coming from the Lambda Power Tools for TypeScript logger. So we can see the function name is injected here, the request ID is injected, which is quite useful when you're doing individual request analysis. We can see the ARN, we can see the memory size, which is pretty handy. The X-ray trace ID is also logged, the file name. And the structured properties that Luciano added were key, ID, and content disposition header. So then the next thing we do is log a metric. And then this is just the EMF metric. So the log metric call, it resulted in that format that Luciano shared previously. So now we should already have a create share metric of 1 being incremented. The namespace is Weshare. The dimensions are also Weshare. Great. Okay. Maybe we can just show how this works with CloudWatch Logs Insights. When you're doing structured logs, this is pretty handy. So let's go for create share log group. And let's run a query on the latest logs. And we still only have one record, but we can have a look at, let's say we want to get all of the keys from a create share function. So we can suddenly go filter function name is create share, and we want to display the key. And this will show the S3 keys from all the invocations of this function over the last hour period. So that's pretty cool.
3 of them, yeah.
3 of them? Okay, nice. So let's have a look for our EMF metrics. So before we look at it in the actual CloudWatch metrics, let's have a look at looking at our metrics through the logs, because we were talking about this. So we'll look for metrics that have the field underscore AWS present. That's how these logs look, I believe. Oh, this is convenient. Okay. Let me switch back. Just gotta re-log in here. I feel like we should have some hold music.
Yes, yeah. Perfect
Green
timing
sleeves.
for the credentials expiring.
Not only my AWS credentials, but also my account credentials have expired. And with any... Oh yeah, and now I have to do multi-factor as well. Everything is coming at once.
Nice. Okay, while you do that, I'm gonna give a brief intro to what we can do next to show another feature of Middy, like using another middleware to do content negotiation. So something very common in APIs is you might want to support different kind of responses. For instance, I don't know, an API can return JSON or XML or plain text. Actually, in our current API, we're returning just a text in plain text saying, this is how you do an upload using curl, and this is the URL for downloading the file afterwards. Because we are going to want to build a front end and a CLI application over time, it might make sense to give back also something that is a little bit more machine consumable. So we will also add the content disposition middleware and make so that if you pass accept application JSON in the headers, you get back a JSON object. Otherwise, you'll get back the plain text. And you are back online with your screen being shared.
I am back. Yep. So we have, let's say, I have to, what I'm trying to do is filter out messages that have EMF value. So then we get, so EMF metrics will have underscore AWS.timestamp. And if we take an example of one of them, we can see the metric, the count for create share is 1. So let's say what I want to do then is I want to do a sum of all the create share values. So I'm basically looking at all the AWS metrics. Yep, actually it might even be better to make sure I'm just filtering for this metric. So I'm looking for AWS metrics that have create share, and I'm going to sum them all, and this should give me the value 3. No, it's not.
I'm doing new ones, so you might get different values because I'm
okay.
Depending on what's the period you use to aggregate, you might get different values.
I think the reason is I need to do underscore AWS.create share. No, that's not working either. But I think you get the idea there. We can look at metrics on an individual level here. So maybe at the same time, I'll just flip over to the metrics. And now in the metrics, we have Weshare, and we can see that we've got a download share metric and a create share metric. So let's click on the create share metric. Have you also done some downloads, Luciano?
I've done a couple, so we should have download share. We do have them, right?
Okay, so let's have a look at that. So let's say we look at the sum for a 1 minute period in CloudWatch metrics, and we'll zoom into the last 15 minutes. So we can see we have a create share, we have 2 create shares, we have a download, and we have an upload later. And we could even take that further and do a ratio if we wanted to. But we probably we need more users before this starts to become really meaningful. We can look at X-ray also. Will we give that a go?
Yeah, let's do it. I'm curious. I haven't personally used X-ray that much, so I'm curious to see how it looks like.
So I think we can see, let's see what we see. We don't see anything for the last 5 minutes yet. Let's try it.
Yeah, there might be a little bit of lag.
There might be a delay. Okay. I would expect to see a service map. I would expect to at least see some Lambda traces at this point. Okay, let's come back to it. There's no point in sitting here waiting for X-ray to refresh. So maybe we can go on ahead with the next step.
Okay, so the next step is to add let's try this content disposition thing. So the first thing that we want to do is to add, we need to add a couple of additional Middy middlewares. So we need to do npm save, content negotiation, and we also want the header normalizer. So content negotiation is part of the HTTP spec. So you can basically pass a header called accept, where, well, different headers, but basically you can negotiate the content type. So what kind of response do you want? Do you want a JSON? Do you want a plain text? Do you want an XML? Do you want something else? You can negotiate language. For instance, if it's an API that supports multiple languages, you can have your response in English, in Italian, in, I don't know, any other language that might be supported. You can also negotiate encoding. So is it UTF-8 or is it something else? So the HTTP protocol specifies how to, as a client, submit your preference. And then depending on what's supported on the server might say, yes, I can support this specific request. And actually the response is going to be finely tuned for the preferences that were specified by the client. So in our particular case, what we want to do is basically the simplest thing ever. So if we send as an header accept application JSON, then basically we want to return a response that is a JSON object. Otherwise, we'll return the plain text response that we have already. So let's see if we manage to do this change without troubleshooting for another half an hour. So fingers crossed. So we need to import the two middlewares, so HTTP content negotiation from HTTP content negotiation, that's correct. Import HTTP header normalizer from Middy HTTP header normalizer. Now, the way we use them is interesting because basically we need to add them here. And basically what we want to do is use HTTP header normalizer first, and then use HTTP content negotiation. Now, this one might be configured, and basically what we want to say is that we don't really care about parsing the char sets, so we can say false. We don't really care about parsing the encoding, so we can say false. We don't really care about parsing the languages, so we can say false as well. And the only thing that we care about is parsing the content type, which by default is true, so we don't need to say that explicitly. Now we can say available media types. And this is an array where we can say text plain, which is the default, and then application JSON. Close enough, Copilot. And what is going to happen is basically that in our Lambda logic, we are not using this information yet, but every time that our Lambda is going to be triggered, it's going to receive the event, and this middleware is going to look at that event, all the headers, and it's going to try to decide, is the client expressing any preference? At that point, if it's able to kind of negotiate based on this configuration, what the client sent, we are going to have our event being enriched with a bunch of configuration options. And for instance, what we can do is here basically we are just returning a body as a string. So what we could do is basically say something like that, let body is equal to all of this, and then we just return the body. We could also say if event.preferred media type equal to application JSON, if I'm typing this correctly. So this is basically a default case. Here we are saying preferred media type is something that is coming from the middleware. So the middleware is creating this additional property on the original event object. and it's telling us I did all the content negotiation, and this is the preference of the user based on what the server actually supports. So at this point, what we know is that basically the body can be reset to JSON.stringify, and this needs to be an object where the only things we care about are file name. Then we can have headers, and headers is content disposition header. And then we can have the URL, which is download URL. And we also need the upload URL. So the difference is that in this case, we're going to be returning a JSON response. So it's going to be machine readable. So when we build the CLI, we don't need to try to extrapolate text from a plain text. In this case, we'll be able to just take it as a JSON property. We can get all the headers and we can get the upload URL. Another thing, if we are really picky, that we can do, we can have headers, just as a best practice. Let's say let headers equal, and we can say content type text plain. This is the default. And here we can also reset the headers and say headers equal content type application JSON, and we can also return the headers.
Okay, so those are the headers for the HTTP response. Yeah.
Exactly. Does that make sense or not? We can just test it and see if it works.
That makes sense to me, yeah. Yeah. So the middleware isn't we have to still set the headers ourselves. The middleware isn't going to automatically somehow figure out what our response content type should be.
Exactly. So it just tells us, based on the user preference and what you told me you support in this configuration, this is the best that we can possibly do. But then we still need to use that information and implement a different piece of business logic. Now, there is also a response serializer middleware we use in combination. So we could have used that as well, but I just wanted to keep it simple. So we could have implemented different serializers and implement our logic as a serializer instead. But another thing I want to do before we get there is this fail on mismatch. By default is true, if I remember correctly. If we put it to false, basically we are saying it is fine if a user doesn't send us an accept header. We are just gonna ignore any preference, and at that point in our code we are defaulting to text plain. If you want to be strict, which is the default behavior, this will be true. What happens if if the user doesn't send you an accept header, or if they send you a value that is not supported, like if you cannot negotiate any format that makes sense on both sides, in that case it's going to return an HTTP error, I think 406, which I believe it means something like not acceptable or something like that.
Okay.
So it's basically returning the proper status code saying this particular request cannot be fulfilled effectively. Okay, so let's deploy. Let's deploy. And fingers crossed that we did everything correctly. While we wait, feel free to ask any question in the chat.
I shared a link to the 406 HTTP cat in the chat.
Oh, nice.
Great. Okay, this is deployed. What's your confidence level that this will work first time, Luciano?
50%. After all the failures.
I'd take that.
So let me clear up. This is the post. How do you do in curl to see the headers? Is it
-v. -v works for me. Yeah, that will print the request headers and the response headers.
okay? So it didn't fail, and we can see that the content type is text plain, and
Great.
this is what we are getting, which is the same as before. So we get like a textual response, basically. Now, if we want to change this, what we need to do is to say h and say accept application JSON if my memory is correct. And this is giving us now a JSON object.
Nice.
And we can use JQ, I believe. See it a little bit better. Let me make this bigger. So you can see that the file name was package.json lock, headers, the headers that are expected. This is the upload URL and download URL. So now we can go and implement our CLI. I don't know if we're going to have a lot of time to finish it, but let's make a start.
Yeah, let's give everyone an appetizer.
Okay.
Should we commit what we have so far?
Actually,
so people can explore the repo.
So added Middy, PowerTools, and content negotiation. Okay, fair enough. So one way that we can do the CLI is as a new package, right? So we can just do a new folder and call it CLI, and then do everything inside there. So I'm just gonna do cd CLI and npm init y, and we have a new package JSON.
Can I ask a question about the intention or the goal with the CLI in general, Luciano?
Sure.
So right now you can use curl. It gives you an ugly upload URL and a nice download URL. So is the idea for the CLI that we use it for uploads or downloads or both? Is it just, yeah?
So I was thinking to use it only for uploads, at least as a starting point. It's just like an easier way. Like if you're working on the CLI, you can just say whatever we call it. Like if we call the CLI Weshare, you can just say Weshare and a file, and it's going to do everything for you. You don't have to remember how to construct the curl, what's the domain name, and all that kind of stuff. We're going to do it in a pretty simple way, I think, for today. So everything is like hard-coded. As we improve our code, our backend, for instance, as we add authentication, probably we will want to make the domain name generic. We might add to our CLI also kind of a login step, and it creates a configuration file for you. And then you just log in once to whatever is your deployment of Weshare with your credential, and the CLI is going to remember all of that. In a way, similar to what the AWS CLI does. Like everyone has a different account. The AWS CLI, the first time you configure it, and then it's going to remember all your settings, and you can keep using the AWS CLI. Of course, we're not going to do anything as advanced as the AWS CLI, but that's kind of the general idea.
It makes sense because the download your experience is fine right now. You give people a link and it works. So yeah, we just need to make the upload experience more friendly.
Yeah, so when it comes to create Node.js applications on the CLI, there are many frameworks and libraries that you can use that make your life a little bit easier in terms of parsing arguments and providing help messages to a user that is trying to figure out how to use the CLI. There are two that I particularly like. One is Commander.js, and the other one is called Yargs, which has a pirate theme, and the website is actually really funny. So I think for today we're just going to use Commander because, I don't know, I find it a little bit easier to get started with. Maybe it's a little bit less customizable, but it's more intuitive, I think, to use it for simple stuff. So
Good.
we'll need
I
to,
found Yargs a bit difficult, I must say.
yeah, it's way too configurable, which can be useful in some cases, but the first time you look into it, it's a little bit confusing. So we are gonna save Commander, which is the other one. By the way, if anyone adds other preferences for CLI tools for Node.js, definitely drop them in the chat because I'm curious. Okay, so let's see at this point how can we use Commander and how. Let's start to create a file. For instance, let's call it new file CLI.js. And by the way, when you want to create a package in Node.js that exposes CLI applications, there is actually an interesting thing that you can do. You can go in your package.json and say something like this. You can basically say bin. And bin is basically saying in this project, there are CLI tools being exposed, and you can give them a name and a destination file. So here, Copilot is basically saying, I'm going to call it CLI, but in reality, we want to call it something like Weshare. So it basically means that it's going to create, let's say, an executable file called Weshare, and then that Weshare is going to point to the CLI file in this particular package. So in reality, every time in your terminal going to be running Weshare, if you install the package globally, you are running the CLI file that we are providing here. Mm-hmm. And in order for that to work, we need to do a little bit more work because we'll need to make this file executable. So we'll need to give it this, what do they call it? Shebang.
Shebang. Yeah.
Yeah, so this is basically telling to all the Unix environments, this is how you interpret this particular file. This is the actual executable that can run this file. And user-bin.env is basically saying, find where Node.js is, and then use Node.js to run this file. But that's not enough, because we still need to do one more thing. We need to do chmod plus x of CLI.js. So that also setting this file as an executable in Linux.
Great. I guess we could, in the bin, we can also create aliases as well. Like I noticed with serverless framework, you can type serverless, but you can also type SLS. So if you wanted to have like a shorthand version, like WSH or something, you could add a second alias bin here.
That's a good idea. Let's do it.
What happens when you publish then these to npm? I presume that these bins have to be globally unique across npm packages. So when people run like npx, for example, it will find it can only find one package. Do you know how that works?
I think if you run npx, you need to do this if you want this to work.
So what does serverless framework do? Because npx SLS works. So do they also publish it as SLS?
That's a good question. We could probably check in the repository if there is a way that in the package.json you can specify aliases for commands. Because we could do here a command called SLS. I don't think it's going to stop us from...
Would it stop us at publication time? I don't know.
Maybe. I don't know. We're worth testing it. If anybody knows in the chat.
I'm going to look at the serverless package and see how they do it. I'm also going to look on npms.
Is to do type modules because it's becoming kind of a standard. Okay, now we can import Commander. So the way you import Commander is by doing this program. And this is basically an object that gives you a builder pattern to define all the description, basically, of your CLI program. So you can say program.name and call it Weshare. Then you can say something like description and say the Weshare dot click CLI tool for uploading files. And then you can add more stuff. For instance, you could say something like add help text, right? And after means after all the description, and we could say something like, I don't know, to upload a file from the local directory, and we could say something like Weshare upload file name, something like that. Actually,
cool.
Let's just do like this. I think it's even easier. So at this point, we only defined the program, basic stuff. So the name, the description, and the text. Now, of course, we need to add an argument because we said we want to support a file name as an argument. And we can say file path, something like that, and say path to the file to upload. And the last thing is the action. So what do we want to happen? And this can be an async function where we receive the file path. This is our argument. And here we can implement, something like this for now. Okay, now let's try to run this to see if it works. So we can say, by the way, if we do npm link, this is another interesting trick. It's going to automatically create only in my machine, it's going to expose that executable globally. So now I should have Weshare, as you can see, and I should be able to do Weshare help, and it doesn't do anything because I probably forgot to initialize it. Yes. So here I'm only creating an object, but of course, in order to execute the logic of this builder, I need to do .parse, and we don't need to do process arguments because that's the default. Now we should get the help. So as you can see, Commander is building all this helper for us based on what we specified in the builder pattern. So we can see the usage is Weshare options file path. Right now we don't have any option except the help. In the future, we might be able to pass a different domain name or authentication parameter, or I don't know, any other stuff. Then the arguments is the file path, description, and we also have all the text we added with the examples. To upload a file from the local directory, Weshare file name. Make sense? Okay, so what do we want to happen here now? We want to read the file path. Actually, before that, we want to call the Weshare post endpoint to get an upload URL with the file path name. Read the file path, upload the file using the pre-signed upload URL, and then print the download URL. Make sense to you as a strategy?
I think this makes sense. Yeah.
Okay.
So read the file path is just to validate that it's correct, is it?
Also, we will need, of course, to upload the entire file. So we'll need a way to read the bytes in the file and send them through HTTP.
Okay.
We will see how to do that in Node.js. Okay, so the first thing is that we'll need something to do HTTP requests. And there is a client that I really like, which is quite new, and it's part of the Node.js repository, and it's called undici. It's kind of an interesting one because as a native, it's like one of the fastest because they kind of re-implemented the HTTP parsing layer. So it's quite performant, and yeah, I think eventually will become part of Node core. Even though
Cool.
Node is also implementing fetch, I'm not really sure because undici is partially compatible with fetch. I'm not really sure if the Node core implementation uses it underneath or if it's a totally different implementation. And yeah, go ahead.
Is this part of the same family as Fastify?
Yes, I think the
Yeah.
authors are
Similar.
original authors are the same, or I think
Okay.
one of them for sure. But then
Yeah.
now it's part of the Node.js foundation. So it's actually the
Interesting.
repository is Node.js/undici. So it was somewhat donated, or I don't know, was taken ownership from the Node.js foundation. And to be honest, we will see it's not too different than using something like Axios or requests. Like at this point, the HTTP clients are almost all the same, or fetch itself, like it's very similar. Do we need anything else? I don't think so. So let's. I think that should be all we need. So let's do a few things. So we need to import a few things to manipulate files. So for instance, we want to get base name from path, from node path, because what base name does is given an absolute path or even a relative path allows us to get only the file name, which is the one we want to use for the content disposition header. So that can be a good utility. Then another thing that we want is create read stream, and we will explain what that means in a second. From FS. So create read stream is basically a utility from the file system module that allows you to read a file rather than reading it only one go, like the entire content of the file given to you into a variable. It allows you to read it incrementally using a concept called streams, which is just an Node.js abstraction for doing kind of streaming data processing. So what we could be doing is we could see that undici allows us to create an HTTP stream when we do the request for uploading, and then we can pipe the file system stream. And what happens behind the scene is that the HTTP request starts, it will start to read the file, and it's going to read the file in chunks and upload it in chunks into the HTTP endpoint. And this is very convenient because if you want to upload files that are multiple gigabytes, you are not going to blow up your memory in your process. It's going to do that very efficiently because it's only going to process smaller chunks at the time, upload that chunk, and then move on to the next one. It's not going to retain all the file content in memory and then trying to upload that. So this is just a best practice every time you deal with files and HTTP requests over files in Node.js. I think it's very convenient to use streams because then you don't have to worry about memory and blowing up the process by just running out of memory. Okay, then another thing that we can do is import stat from FS promises. And stat is a function that allows us to check, first of all, if the path exists, and then if it exists, is it really a file? Because, for instance, if it's a directory, we don't really know what to do with that directory. We can only upload individual files. And what else? Okay, I think the other thing we need is request from undici, which is what allows us to do HTTP requests. Okay, so before actually doing any HTTP requests, let's do all the file system stuff. So let's make sure that the file really exists. So what we want to do is const file name file path, which is what we are receiving here. And yeah, basically what we want to do is, okay, let's just say, I think if we don't pass a file path, that is going to fail. So I'm not going to do any check, and then we can validate that. So we can do base name file path. So this is basically going to say, if we specify a very long path with subfolders, it's just going to give us the actual file name of that particular path. So if you say, for instance, /users, /luciano, /documents, /package.json, it's just going to give us package.json. The other thing is that we want to do is we want to make sure that this exists. So probably we should do that before. So const stats equal await stats file path. And then, of course, this can fail. So let's put everything in a try catch just for good order. And we can do console log and process.exit1. Okay, so here we can do stats if...
What's the import of stats? So what you're calling await stats? Oh, it's stat, yeah.
Stat. Did I?
Single
oh, yeah,
stat,
I
yeah.
misspelled it. Yeah, good point. So here we can say something like, yeah, exactly. Thank you.
Perfect.
File path is not a file. Perfect. So at this point, then we have a file name. We can probably do this later. I think at this point, what we can do is actually do the post request. So
yeah. So this is what we previously did with curl -x post weshare.click/share.
So we want to do share URL response, I guess. And we can say, actually, let's do one thing. Let's do something like base URL.
Okay.
And we can call it HTTPS. I don't know why it's doing that.
Somebody's done this before with S3.
Share.click/share, right?
Yep.
Do we use this also for the post?
For the posts,
I think we did that.
We do, yeah. And for the downloads as well, yeah.
Wait, but to create a share, oh yeah, because we map that with the custom domain. Okay.
You need the, yeah.
Cool. So this is the base URL, and what we want to do is to use a query string. So what we can do is const upload, actually share URL, and we can do a new URL, base URL. And at this point, we can say share URL dot search parameters append and file name. If I remember correctly, we call the query string file name.
That's right, it was, yeah.
Yes, file.
Brilliant.
Okay, so this is basically just making sure that the query string parameter is being set on this base URL, and we don't have to do it manually. This is gonna take care of all the escaping and all that kind of stuff. Now at this point, we can do share URL response equal await request. This share URL. It doesn't have to be stringified because undici also accepts URL objects. By the way, this is a URL object where you can manipulate the URL dynamically. You can also do toString if you want to convert it into an actual URL string. And now we need to configure the HTTP option. So method is not put but post. And we also want to send headers. We want to set... We can send a bunch of stuff. We can send accept application JSON, and then we can send, let's send a user agent, just for fun. Weshare CLI.
Boom, nice.
Okay, and at this point, what we can do is const share URL response body, I guess. I'm running out of name. we can do, I think we can have JSON, if I remember.
Okay.
Okay, and at this point, I'm just going to do a console log just to see that everything.
Yeah, see if we get this far.
Okay, let me move all these comments around.
Is it we're calling .json? I guess the issue might happen that you don't get JSON back because you've got an error code back, like you've got a 500 error, internal server error. So should we check the response status code before we JSON call .json?
That's a good point. So we can say share URL response.status code. What is is 201 the one that we get that indicates success?
Yeah, it's 201 for our case. Yeah.
So if it's different 201, we can say, unexpected status code. You see, something like that. Okay, we could. I guess one thing we could do is const text response. I think text will give us the not body. The text. And at this point, we can also say, I don't know, /n fonts text.
So you have to await. You have to await that text function. It's actually your promise, is it?
Yeah, because basically you start to receive a response as soon as you get the first headers. Then the body is also streaming, so you can start to do work even before all the body is received.
That makes a lot of sense, especially for performance-focused library.
And I think that this one is body.json as well. Let's give it a go. So now we still have this Weshare help, right? So this is still working. Now we can pass, for instance, I don't know, package.json. And let's see what happens. It is working. Nice.
Wow. Amazing.
Cool. So we are very close to complete this, I guess. So the next step is to upload the file. And this is where things get a little bit more interesting. Because at this point, we have the upload URL, right? Actually, let me bring this one back. The things that we care about are these headers. Which I'm realizing now, this is not the most convenient format. We should have done like another. I am regretting this decision. We could quickly change it, and while it's deploying, we'll continue the API stuff. So share handler, basically what we want to do is here is rather than doing content disposition header, we want to do content disposition, right? And what was the value? Do we have only the value?
Yeah, just called content disposition, I think was it? Yeah. In fact, you have. Oh, right. Yeah. Okay.
So while all of that is going on, we'll do an XLS deploy and then
we'll do our upload code.
Okay, so upload the file using the pre-signed URL. So what we want to get from here is headers and upload URL, which will be in this object. So we want to do an upload URL. Thank you, Copilot. And actually, we already have the upload URL. Is going to be this one. So I'm going to use that. So what we want to do is const upload response. And we can do an await request of, all of that. This time the method is put, and the headers will be pretty much just headers from, did we call the object? This one dot headers.
Yeah, that'll give you your content disposition header.
Yeah, so this should work, I think. And assuming that all of that went fine, so what we can do is again check if the response was, the status code was what we wanted. So is it a 200 that we return?
I think so. Yeah.
What does the upload URL returns?
It returns at 200. I'm pretty sure we saw that last time when we were using the dev tools in the browser. Oh, that was the download. I still think it's a 200.
Well, I mean, if it fails, we'll see exactly what's the status.
We'll know.
So at this point, we can just say, yeah, the same thing from a stream, I guess, in this case. And if everything went fine, the only thing we want to do is literally just print the download URL.
Perfect.
Right? Okay, let's see.
So we're not uploading anything. This is the problem, though, right? We're not. We're just doing a put with the URL and the headers.
Oh, yeah.
We don't have any content.
That's a good point. How do we do that?
I don't know. But I'm getting this is your chance to shine out with some of your excellent Node.js streaming chops.
Okay, so basically what I know, and we'll need to see exactly how undici supports that, is basically because a request is a stream, is a writable stream that is going to actually write into the HTTP endpoint that is connected to the S3 server, you can actually pipe another readable stream into it. So what we can do is basically say, we can basically say what's the best way of, we can, first of all, we can create a file stream, const file stream, and we can use the create read stream from the file path. So this is an object that represents a readable stream, so allows us to consume data from the file path. And then I think that what we could do is literally just say, I think we can use the pipeline utility. So we can do from fs promises. No, we need to import from pipeline from stream promises. And what pipeline does basically allows you to combine two streams together. So starts from the readable and you connect the writable part. So it's going to read from the file and write into the HTTP, but also makes all of that operation a promise. So you can easily await for when all the data transfer is completed. So basically what we can do is to say, let's do it in another way. Const upload stream. Let's do it like this. And then we can await pipeline of file stream upload stream. I think that will work, but let's see. One thing that I still want to do just for debugging is console log share URL response body. And this is the upload. Okay. Then we can probably use this to also add a progress bar for future improvements.
So in the previous, when we did the post, we called request and we got back a response.
Mm-hmm.
It looks like now we're calling request, but we're expecting a stream back. How does that work?
When we call, wait, this one, right? Yeah. So the object that you get is also a stream. I think.
It's also a stream? Okay. So
I'm
it
actually
can behave
not
as...
sure if we need to do something
Okay.
with body, and maybe that body stream.
All right, okay. Let's give it a go.
That's a good point.
I'm curious.
Okay, let me quickly review my notes. Maybe I've done that. And I think we might also need to send more headers to... I think we'll need to send the file size to S3. I am remembering something like that.
Okay.
So
You need to send the content length.
Yeah, so let's see.
We can do some error-driven development and just run it and see what happens. Too.
Okay. Let's simplify all of this. I don't think we need to use pipeline because I'm seeing that undici just supports a stream as a body. So we don't need to do all of this. We can just keep doing this. And then we can just say body and file stream. Okay, and then we also need to send...
That's very neat.
So we want all the headers from here. But we also want the... what is it called? Content length, I think.
Content length, yeah.
And stat size. This is also good that we have done that stats, because the stats object tells you if it is a file, you also get the size. That's probably all we need. This will give us the content position. I don't know if we also need to have yeah, exactly that, a content type application of the string. I don't know if that's optional or not. We use it, I think, the first time we implemented this. So let's put that.
Okay.
Okay, this might just work. Let's see if we got lucky. So the deployment completed. So if we go back to, well, at this point we can do it from any folder really. So let's actually upload the CLI script itself. So we can just say Weshare CLI, CLI.js. Okay, and this is the file. So if I go here, I don't know if I can show you that fully. It is downloading a file. I can drag and drop it to VS Code. And it did open download CLI. So that seems to be working.
Nice.
Awesome. So yeah, this basically works. We can just remove the debugging stuff. And where is it? There is a console log somewhere. I lost it.
It's just above there, around 45. Yeah, 47, line 47.
There you go. So the actual user experience that we want is basically that anyone can say, I don't know, for instance, I want to upload ESLint configuration. So I can just say weshare.eslint this, and you just get a URL that I can send any one of you in the chat, and you should be able to download this file until we tear down this stack. So if you're watching the recording, chances are that this is not going to work. Also, I think that we set like 24 hours for this link.
Yeah, on the expiry time, I think it was for the download URL. I'm not sure. Yeah, upload URL was short. Download URL was 24. This is really nice. Well done. That worked surprisingly smoothly.
I'm gonna commit all of this, and next time we can be fancy and add progress bar and stuff like that. Do we want to wrap up here for today?
That sounds really good. Yeah, I mean, this is a really nice user experience. The only thing it's missing is some security defense mechanism against people uploading files onto your bucket. and you incurring the cost. So I think authorization is a pretty important next step. So we could add an API key if we wanted to do it simply. I think that would mean that we would have to change from using HTTP API to using the REST API method in API Gateway, because the HTTPI method, while it's simpler and faster and cheaper, it doesn't support API keys. Then we could also use like a Cognito authorizer, so actually support federated all login with Google or Cognito user pools. So that's a good opportunity to dig into Cognito, which is something we haven't covered in depth on AWS Bytes yet. So it's a nice opportunity to dive into all the joys and pains that come with Cognito.
Yeah, it might also be cool to show how to improve our CLI, then to be able to do like a login once.
Yeah.
And then once you're logged in, it will retain that information for you and you can keep uploading more files.
Yep. That sounds really nice. Thanks a lot, Luciano, for driving everything today. I think that was really productive. We came to a really good place, and now we don't have to worry about those really long URLs anymore. That makes me very happy. So thanks everybody for listening and joining. And please...
There is one service information. We are not going to do the stream in next week for sure. Let's see if next week we'll be back, but stay tuned on our social media or on the AWS Bytes YouTube channel. We'll be publishing the next stream whenever we'll be able to do it.
Okay, great. And I can hear the ice cream van in the background, Luciano, so you better run and get yourself something. I think you deserve it after all that. Thanks everybody for listening. Talk to you next time. Goodbye.
Bye. Thank you.